another activity we did today. There's a link to the worksheet that goes with this. This is the first page of that. So we did the first page together. Okay. We're going to identify all the relative maxes and mins, points of inflection, intervals of increase and decreasing, intervals of concave up and down, and we're going to assume all the relevant values have been given. So in other words, you've been given all the relevant values. All right. All right. So first of all, let's identify the maxes and min if we can. Okay. All right. So let's see. So how do we identify the max and mins? Well, first of all, we look at the first derivative where the first derivative is 0 or undefined. We've got two values where it's 0. Okay. So I'm using the second derivative test. I look at the second derivative value. At x equals -1, the first derivative is 0, so x equals -1 is a critical number, and the second derivative is negative, therefore, this is a max. So, max at -1, the y value is 1.5 because the f of x value is given, so it's -1, 1.5, that's the max, right? I used the second derivative test to get that value, or get that, to conclude that. And then I come over here, at x equals 3, there's an f of x is 0, f prime of x is 0, and then the second derivative is positive, so that's going to be a min. So there's a min at 3, -0.5. Okay, there's a min at 3, -0.5. I don't have to zoom out a little bit. I don't know if that's going to be good enough. Let's see. Hope so. All right. Now let's look at intervals of increasing and decreasing. Okay, intervals of increasing and decreasing. So it's increasing from. Okay, so now look at the first derivative. So to the left of -1. So anything less than -1. So negative infinity to -1 is increasing. And then you're like, there's no other positive values. But remember, this was a min. There's a min at x equals 3. So that means after x equals 3, it's increasing. Because remember, that's a min. It was confirmed there's a min because of the second derivative test. So we know it has to be going up from there. All right, it's decreasing. So you got a negative value here. From, what is that, -1 to 3. So that's it. So those are the intervals of increasing and decreasing. All right, let's talk about concavity. All right, I don't have enough space where you can see the table and me right at the same time. So concavity, so you got concave down here, right, and concave up here. So it's negative on this side of x equals 1, and positive on this side of x equals 1. So it's concave down from -infinity to 1, right? Because that's the x value, right? And here, the second derivative 0. Oh, I'm sorry. I should have pointed that out first, right? You're looking for where the second derivative is 0, right? And that's, so one side is going to be positive or negative, hopefully, right? And it's concave up on this side. So from 1 to infinity, it's concave up. All right? So that makes x equals 1 a point of inflection. So the point of inflection is 1, 0.5, right? Because the concavity changes from negative to positive at x equals 1. So that's the point of inflection. Okay, so the point of inflection is 1, 0.5. What else are we looking for? That's it. We did everything. All right, so we've identified the max and min. We've identified the intervals of increasing and decreasing, and we identified concavity. All right. Now, some of you might be wondering, what happens if the second derivative fails? Can we do the first derivative test by looking at this chart? And yes, we can. So, okay, so let's confirm this. So we know that x equals -1 was a max by the second derivative test, right? The second derivative is negative, so this x equals -1 value had to produce a max. Now, you can use the first derivative test by looking before that. It was increasing and then decreasing after that. So by the first derivative test, it is also a max because it was increasing because it's positive and then decreasing after that because it's negative after that. So by the first derivative test, it is also a max. Okay? All right. That was the example we covered in class. Hopefully, it makes some sense. All right. Good luck.